This one is a induction motor equivalent circuit. R1 stator resistance, X1 stator inductance, and Xm mutual inductance between stator and rotor, and this is a rotor reactance, and this one is a mechanical load equivalent electrical parameter. Understood? So this one is an equivalent circuit of an induction motor circuit. So we are going to discuss about torque and slip characteristics. So torque produced because of slip only. Understood? So what are the variations of torque and slip? This is what we are going to discuss here. So from this, if we solve this equivalent circuit, and we will get this expression. Mathematically we can check it in textbooks. So for derivations, very small derivation. So this is what torque. This torque 1 by omega s into V by R equivalent plus R2 by S whole square plus S equivalent X equivalent plus X2 whole square into R2 by S. R2 rotor reactance, X equivalent reactance of stator and rotor reactances, X2 rotor reactance, R2 by S mechanical equivalent of electrical parameter, load equivalent of electrical parameter, R equivalent. So what does it mean? So from this you can solve here. This is the final expression for torque. Understood? Torque is inversely proportional to omega s, synchronous speed in radians per second. You know, omega is a 2 pi n. We know that omega is a speed 2 pi n. N represents rpm, n represents in rpm, and omega measures in radians per second. Relation between omega and n is a omega is equal to 2 pi n. We know that. So torque depends on omega s, V square, where V square is the applied voltage, R2 by S rotor resistance, S represents slip, R equivalent plus R2 by S whole square, and X equivalent plus X2 whole square. This is what a torque. So based on this torque equation, so which is also a function of S slip. Understood? So we have to derive a relation between a torque and slip, and also according to our syllabus we have a characteristics, means variations between torque and slip, means when slip varies how torque affects. We will see this. So observe here, this is what a torque speed characteristics. So remember, it may be torque slip characteristics or torque speed characteristics. You can check in the textbooks. So torque slip or torque speed, both are same characteristics, because speed is inversely proportional to slip. Understood? Once check from this expression. Check from this expression. If you observe here, slip is equal to ns minus n. This is the speed of a rotor. This is the speed of a rotor. Whenever it says speed, it's a speed of a rotor. Whenever it says synchronous speed, it's a speed of a stator magnetic field. Understood? So suppose, for example, if speed of the rotor increases, from this derivation, if speed of the rotor increases, what about slip? Decreases. Suppose if speed of the rotor decreases, what about slip? Increases. Understood? So remember, so n varies from 0 to ns. I'm repeating, n varies from 0 to ns only. Means n equal to 0 means rotor is not rotating. N equal to ns means rotor speed attains to the synchronous speed. Understood? So these are the two chances of n value. So if n equal to ns, then slip equal to 0. That's what here it is written. If rotor runs at synchronous speed, s equal to 0. Understood? If n equal to 0 means, if n equal to 0, s equal to, please, n by n, s equal to 1. Understood? So that's what here it is written. If rotor is stationary, s equal to 1. If rotor runs at synchronous speed, s equal to 0. So s varies, slip varies from 0 to 1 if n varies from ns to 0. Understood?